Yes, a wireway can be installed to tap a feeder. Overcurrent protection is required at every point where a branch circuit originates. In this case, the tap from the feeder is considered a branch circuit. There are two options for providing overcurrent protection for the tap. Firstly, install a circuit breaker in the wireway before the tap. The circuit breaker rating should be sized appropriately for the conductor size and amperage of the tap. Secondly, use a listed feeder tap device that is designed to provide overcurrent protection and maintain the integrity of the feeder. These devices typically have built-in fuse holders or circuit breakers. The conductor size for the tap should be the same or larger than the conductor size of the feeder. Install the wireway securely and support it according to NEC requirements. Ensure that the tap conductors are properly terminated and connected to the feeder conductors. Keep the tap connections as short as possible. Provide drip loops for any conductors that may be exposed to moisture. Additional considerations to keep in mind is to check with the local authority having jurisdiction, or OJ, for any specific requirements. Consider the load requirements of the equipment being connected to the tap. Ensure that the wireway has adequate space and accessibility for maintenance. According to the National Electrical Code, NEC Section 240.21, location in a circuit, overcurrent protection shall be provided in each ungrounded circuit conductor at the point where the conductors receive their supply except as specified in 240.21 F3H. So, if you are tapping a feeder, it is very important to provide overcurrent protection. There are tap rules within 240.21 that could potentially apply, but those must be followed precisely. For example, 240.21 burn covers feeder taps not over 10 feet long. This section specifies conditions that must be met, including that the ampacity of the tap conductor shall not be less than the combined calculated loads on the circuit supplied by the tap conductors, and shall not be less than the rating of the device or overcurrent protective device supplied by the tap conductors, and shall not exceed 10 feet in length, and the tap conductor shall be enclosed in a raceway, which shall extend from the tap to the overcurrent protective device, enclosure, or equipment. Another example is 240.21b2 feeder taps not over 25 feet long, which has similar requirements. Always consult the NEC for the specific requirements based on your installation. The ampacity of the conductors is a critical factor. NEC Table 310.16 provides ampacity ratings for conductors based on their insulation type and temperature rating, as well as the ambient temperature and the number of current-carrying conductors in a raceway or cable. It is crucial to select conductors with an ampacity sufficient to carry the load and to apply any necessary adjustment or correction factors as specified in NEC. When selecting a circuit breaker or fuse for overcurrent protection, it is important to coordinate the device's interrupting rating with the available fault current at the point of installation. The interrupting rating is the maximum fault current that the device can safely interrupt without failing. Exceeding the interrupting rating can result in a device failure, potentially leading to equipment damage, fire, or injury. Electrical drawings and diagrams should accurately depict the wiring configuration, conductor sizes, overcurrent protection devices, and other relevant details of the electrical system. These drawings serve as a valuable reference for installation, maintenance, and troubleshooting. They should be kept up to date to reflect any changes or modifications made to the system. Grounding and bonding are essential for electrical safety. Grounding provides a low impedance path for fault current to return to the source, allowing overcurrent protection devices to operate and clear the faults. Bonding ensures that all metal parts of the electrical system are at the same electrical potential, minimizing the risk of electric shock. Grounding and bonding should be performed in accordance with NEC Article 250. When working with electrical systems, it is essential to follow safe work practices. Always to energize circuits before working on them, and use appropriate personal protective equipment, such as gloves, safety glasses, and insulated tools. Lockout/tagout procedures should be followed to prevent accidental re-energization of circuits. Electrical inspections are typically required to verify that electrical installations comply with the NEC and other applicable codes and standards. Inspections are performed by qualified electrical inspectors who have the knowledge and experience to identify potential hazards and ensure that the installation is safe and code compliant. Electrical maintenance is essential for ensuring the continued safe and reliable operation of electrical systems. Maintenance activities should include periodic inspections, testing, cleaning, and tightening of connections. Any damaged or worn component should be replaced promptly. The authority having jurisdiction plays a vital role in enforcing electrical codes and standards. The AHA may be a local building department, electrical inspector, or other regulatory agency. It is important to work closely with the AHA to ensure that electrical installations comply with all applicable requirements. The NEC is updated every 3 years to reflect changes in technology and industry best practices. Staying up to date with the latest edition of the NEC is essential for electrical professionals. Continuing education courses and industry publications can help you stay informed about the latest code requirements. Proper planning is essential for any electrical installation project. This includes determining the load requirements, selecting appropriate conductors and overcurrent protection devices, and developing detailed electrical drawings. Careful planning can help minimize errors, reduce costs, and ensure a safe and code-compliant installation. When selecting electrical equipment, it is important to choose products that are listed and labeled by a recognized testing laboratory, such as UL or ETL. Listing and labeling indicate that the product has been tested and found to comply with applicable safety standards. Using listed and labeled products helps ensure that the electrical system is safe and reliable. NEC Article 110 contains general requirements for electrical installations. This article covers topics such as wiring methods, equipment installation, and working space around electrical equipment. It is important to comply with the requirements of NEC Article 110 to ensure a safe and code-compliant installation. NEC Chapter 3 covers wiring methods and materials. This chapter provides requirements for various types of wiring, including raceways, cables, and conductors. It is important to select the appropriate wiring method for the application and to comply with the installation requirements specified in Chapter 3. NEC Chapter 4 covers equipment for general use. This chapter provides requirements for various types of electrical equipment, including switches, receptacles, luminaires, and appliances. It is important to select equipment that is suitable for the application and to comply with the installation requirements specified in Chapter 4. NEC Chapter 5 covers special occupancies. This chapter provides requirements for electrical installations in special occupancies such as hazardous locations, healthcare facilities, and places of assembly. It is important to comply with the requirements of Chapter 5 when installing electrical systems in these occupancies. NEC Chapter 6 covers special equipment. This chapter provides requirements for electrical installations involving special equipment, such as electric signs, elevators, and swimming pools. It is important to comply with the requirements of Chapter 6 when installing electrical systems for these types of equipment. NEC Chapter 7 covers special conditions. This chapter provides requirements for electrical installations under special conditions such as emergency systems, standby power systems, and fire alarm systems. It is important to comply with the requirements of Chapter 7 when installing electrical systems under these conditions. NEC Chapter 8 covers communication systems. This chapter provides requirements for the installation of communication systems such as telephone, data, and cable TV systems. It is important to comply with the requirements of Chapter 8 when installing these types of systems. NEC Chapter 9 contains tables and examples. This chapter provides useful tables and examples to help with electrical calculations and design. The tables in Chapter 9 can be used to determine conductor ampacity, conduit fill, and other important parameters. Always refer to the latest edition of the NEC and consult with a qualified electrical professional for specific requirements and guidance. This information is for educational purposes only and should not be considered a substitute for professional electrical advice. Always prioritize safety and comply with all applicable codes and standards when working with electrical systems. Remember to properly size the wireway, considering not only the number of conductors but also the heat generated by those conductors. Overcrowding a wireway can lead to overheating, which reduces conductor ampacity and can create a fire hazard. The NEC provides guidelines for directing conductor ampacity based on the number of current-carrying conductors in a raceway or cable. Also, the type of wireway is important. Some wireways are rated for specific environments, such as wet locations or hazardous locations. Make sure to choose a wireway that is suitable for the environment in which it will be installed. When making taps in a wireway, use listed connectors that are designed for the purpose. These connectors provide a secure and reliable connection and help prevent accidental disconnections. Avoid using wire nuts or other unapproved methods for making taps. Consider the accessibility of the wireway for future maintenance and repairs. The wireway should be located in a place where it can be easily accessed for inspection, troubleshooting, and repairs. Avoid installing wireways in locations that are difficult to reach or where access is obstructed. When running conductors through a wireway, make sure to support them properly to prevent strain on the connections. Use cable ties or other approved methods to secure the conductors to the wireway. Also, avoid bending conductors too sharply, as this can damage the insulation and reduce their ampacity. Properly labeling the wireway and the circuits it serves can help prevent confusion and errors during future maintenance or repairs. Use permanent labels that are clearly visible and easy to read. The labels should identify the circuit number, the voltage, and the load served by the circuit. Surge protection is often overlooked but can be a valuable addition to an electrical system. Surge protection devices protect sensitive electronic equipment from voltage spikes caused by lightning or other electrical disturbances. Consider installing surge protection devices at the main service entrance and at downstream panels to protect your equipment. Power quality is another important consideration, especially for sensitive electronic equipment. Poor power quality can cause equipment malfunctions, data loss, and premature equipment failure. Consider using power quality monitoring equipment to identify and correct power quality problems. Harmonic distortion is a common power quality problem caused by nonlinear loads such as electronic ballasts and variable frequency drives. Harmonic distortion can cause overheating of conductors and equipment, as well as interference with communication systems. Consider using harmonic filters to reduce harmonic distortion in your electrical system. Energy efficiency is becoming increasingly important as energy costs continue to rise. Consider using energy-efficient lighting, motors, and other equipment to reduce your energy consumption. Also, consider using energy management systems to monitor and control your energy usage. Regular infrared scanning of electrical equipment can help identify hotspots caused by loose connections or overloaded circuits. Infrared scanning can help prevent equipment failures and fires. Consider incorporating infrared scanning into your electrical maintenance program. Insulation testing is another important part of electrical maintenance. Insulation testing can help identify degraded insulation, which can lead to electrical shock hazards and equipment failures. Consider using a megometer to test the insulation resistance of conductors and equipment. Ground fault circuit interrupters, or GFCIs, are required in many locations to protect people from electrical shock hazards. GFCIs monitor the current flowing in a circuit and trip the circuit if they detect a ground fault. Make sure to install GFCIs in all required locations and to test them regularly. Arc fault circuit interrupters, or FCIs, are designed to protect against fires caused by arc faults. Arc faults can occur when there is a break in the insulation of a wire, creating a spark that can ignite nearby combustibles. FCIs are required in many locations, particularly in bedrooms. Make sure to install FCIs in all required locations and to test them regularly. The NEC requires that all electrical equipment be properly maintained. This includes cleaning equipment, tightening connections, and replacing worn or damaged parts. Regular maintenance can help extend the life of your equipment and prevent costly repairs. Short circuit studies are performed to determine a maximum fault current that can occur at various points in an electrical system. This information is used to select overcurrent protection devices with adequate interrupting ratings. Coordination studies are performed to ensure that overcurrent protection devices are coordinated to minimize the extent of an outage when a fault occurs. Coordination studies help prevent nuisance tripping and ensure that only the affected portion of the system is de-energized. Load calculations are performed to determine the amount of power required to serve a particular load. Load calculations are used to size conductors, overcurrent protection devices, and transformers. Voltage drop calculations are performed to determine the voltage drop that will occur on a circuit under load. Excessive voltage drop can cause equipment to malfunction and can reduce the efficiency of the electrical system. Transformer sizing is critical to ensure that the transformer can adequately supply the load without overheating or experiencing excessive voltage drop. Consider the load characteristics, the ambient temperature, and the transformer's nameplate rating when sizing a transformer. Power factor correction can improve the efficiency of an electrical system by reducing the amount of reactive power that is drawn from the utility. Power factor correction can also reduce energy costs and improve voltage regulation. Electrical safety training is essential for all employees who work with or around electrical equipment. Training should cover topics such as electrical hazards, safe work practices, and lockout/tagout procedures. Emergency procedures should be established and communicated to all employees. These procedures should cover topics such as what to do in the event of an electrical shock, a fire, or an equipment failure. A qualified electrical professional should be consulted for all electrical work. A qualified professional has the knowledge, skills, and experience to perform electrical work safely and in accordance with applicable codes and standards. Always obtain the necessary permits before starting any electrical work. Permits ensure that the work will be inspected and that it complies with applicable codes and standards. Keep accurate records of all electrical work that is performed. These records should include the date of the work, the name of the person who performed the work, and a description of the work that was performed. These records can be helpful for future maintenance and troubleshooting.